So far what we've done is, what do you always try first?
Greatest common factor.
Good, so I call it step 0, right? GCF is what you always try. And before I get too far, anybody not get this factoring handout yet? Who else? Sorry. Now, obviously, if you look at this thing, there's a good reason why I put this little box at the top. That's your little quick reference. Because it's really difficult to give you something that's worthwhile to look at that isn't quite loaded like this, right? So you can look up here for a quick reference and then go to the section that talks about how to do that problem. How do you determine what kind of problem you're looking at?
The number of terms?
I love it. The number of terms. They have 4 terms, grouping. 3 terms, trial and error, or surefire. 2 terms you're going to talk about today. And one of them must be that cube thing we were looking at earlier, right? So that's why I have the little quick reference. How many terms is it tells me what to try, and then if you're doing your homework, you can go to that section just to focus on how does that type of thing work. So don't look at the whole thing at once. It's a little like, holy crap. I understand. So it's GCF. And then we look at the number of terms. 4 terms means grouping. 3 terms means it looks like this. So if the first thing is a 1, should be relatively easy. That's what I call trial and error. Let's do an example real quick. We just did a couple earlier, but let's just do one that's a little bit freakier. So these kind of problems, it's all about remembering how to attack a problem. Right? I don't want the problem to be, I don't even know what to try here. I want, if there is a problem, I want it to be, okay, I know what to try here, but I can't remember how to do that. So what kind of problem is this? There's 3 terms. The first number is a 1, so what does it really boil down to? What do I want to focus on?
We got 2 x's.
Okay, good. So I know I can do x squared, there's no mystery there. It's x and x. But 42 could be lots of different things. I need the ones that specifically make it work. They gotta, I like it, they gotta multiply to be 42, negative 42, and add to be negative 11. So let's see. We got 6 and 7, but would they make 11? No. But it's a good try, right? You just got to brainstorm. This is why it's called trial and error. You try it, it didn't work. Okay. 14 and 3. So remember, I don't know if you guys, and if anybody likes this, the 6 is 2 times 3. So can't you do, there's the whole thing, right? 2 times 3 times 7. That's what 42 is. I like it. So here's 14 and 3. If I rearrange it, which one's got to be negative? The bigger one. I love it. And then how many more steps do I have? Plug them in. I'm done. So I got 1 step left. Put them in. So if it's 3 terms and your first number, the first coefficient is a 1, don't make more of it than it is. It's just find the numbers that work. Because like you keep telling me, the x squared is x and x. That part, no mystery. It's the last part that's a bit of a mystery. How do I break it up to make it work? Okay, cool. And if a is not 1, that's what we worked on last time. If a is not 1, you get a problem like, oh crap, now I gotta make one that works. By the way, do you guys notice I don't have this like big bag of problems at work? And if I'm not careful, if I just slap something down here, is it gonna work? I would put money that it doesn't. And that's the reality. I want you to understand, a lot of these functions, most of them will not work. So we learn this so we can learn better methods to handle things I don't know, because a lot of times the new method is based off the old one. So we gotta first learn, how do I do it if I get a nice problem that I actually do this with? So what's the first step here? If the first number is not a 1, what do we have to do? I like it. We gotta take that into account. 6 times 10, 60. And watch this. This was a 1, right? Didn't I still do 1 times negative 42 and it stays negative 42? So we've actually been doing that the whole time. It's just if it's a 1, it doesn't change it. It doesn't mess with it. If it's something other than 1, it's going to mess with it. So now what factors does 60 make 23? I like it. 20 and 3. That one wasn't too harsh, right? So 20 and 3 multiply to be 60, and they add to be 23. So what do I do with the 20 and the 3 in this case? What's the whole point of the surefire method? I give you 3 terms, and it tries to make it into 4. Because then what method can I use once I get 4 terms? Grouping. And grouping, you guys are starting to believe me more and more about this. Grouping is easy, especially when you start learning the other methods that are more difficult. So if I break up that middle term, 23 is 20 plus 3. 6x squared plus 20x plus 3x plus 10. Let me put that up here. So like we just said, surefire helped me figure out the 2 numbers to put in the middle. I've got 4 terms now, so now I can So what comes out of the first 2? Comes out of these 2 here. 2. They both are even, and then 1x can come out. Yes, sir. We could have. I kind of did this on purpose, though, just in case this comes up. Sorry, so you get 3x plus 10. Now, do you notice how that's there? And what comes out of here? You actually had a good thing earlier. What's the only way I can factor this? What comes out? A 1. Because it's prime. So actually write it like that. Take a 1 out. So what's left? The same damn thing. Why would I do that? Because now I can see what goes here. So you see 2x plus 1 with a 3x plus 10, right? Okay. So that process, the surefire method, is definitely one of the ones that students don't like. So if you have another way that you do it that works better for you, continue doing it that way. Just make sure I can see the steps. That's not the only way to do that problem.
Do you follow that once you...
To check yourself, you could foil it. But I want you to realize, simplifying, foiling out and stuff like that is the opposite of factoring. Factoring says break it up. Simplify says multiply it together. They're opposites. So if I say factor, make sure you stop here. Cool. And when I say simplify, don't factor. That's the opposite. Yeah.
Let's see, because now four term, right? The equation on the top, 6x squared, yeah. So yeah, but we can add 20x with the 3x. Why you don't do it?
Because then I'm right back to where I started. So I agree with you. We could put the 20 and the 3 to get 23. But the reason that this gave me these 2 numbers is that's the only 2 numbers I can put in there to make the grouping work.
Yeah,
what adds up to be 23? A lot of things.
Yeah.
But it's only 20 and 3. If I break it up like that, the grouping will work.
So, okay, my question is, you give an equation 4 term, okay, and you need the factoring, okay. Will be maybe same this one? We
Could be.
Start with this same one?
It could be.
I mean,
So if they give me a problem like this is how it starts,
yeah.
don't automatically put the like terms together. try to group it first, right? Because then you might be giving yourself more work. Certainly. If there are like terms in here, but it's 4 terms, try to first use grouping. Definitely. Because they might have given you one with this already broken up. So that might have happened in the homework. I can't remember off the top of my head. Okay. So, don't worry about it. Today I've got, in addition to the practice test, I've got a little worksheet that you're all going to work on together that has all the different versions of factoring mixed up, which is, of course, the way you're going to see it on the test. Because one big thing you have to learn is how to identify what kind of problem it is. And then it'll show me, do you know how to actually do that problem? All right, so identification is key. So right now we're going to talk about 6.4. Yeah. And there's always 2 major ways I could start this section. So I'm just going to flip a coin in my head, figure out which way I want to go. Okay.
The easy way.
The easy way, all right. Well, let me start with this here. This is nothing special here. This is old news, and I want to build on this to show you the new news. So help me out. What 2 numbers do we need to make this work? Beautiful. They got to multiply by 25 and add to be 10. So 5 and 5 make 25. If they're both negative, they make negative 10. So that's old news, right? So here's the new stuff. And it's the same idea. What's missing here compared to here? Yeah, in fact, be less specific. The middle term is missing, right? Isn't it, would it be okay if, would anybody, this looks weird if I do this, but if I put a +0, can't I really do that almost anywhere I want to? Because do I affect anything when I add 0? No. So the middle term is actually a 0. The middle term canceled, so it's gone. So what 2 numbers do I need? I need 2 numbers that multiply to be negative 25, and they cancel each other out. So they have to be opposite sides, right? So in this case, they have to be plus and minus, 5 and 5 in this case. Because then what do you get for a middle term? 5x minus 5x cancels. So if you have 2 terms, one thing it could be is this type of problem, which is called a difference of squares. And you see why we call it that? Because it's a difference of 2 things that are squares. X is obviously squared, and 25 is 5 squared. So x, how many x's are right here? 2. So I put 1 there, 1 there. How many 5s are in there? 2. So I put 1 there, plus minus to make the middle term go away. Bam. You don't believe me yet, but this is what I call a thank God problem. Because if you can identify it as a difference of squares, you cut everything in half, plus minus, you're done. So let me keep going. Let me show you some more examples. So real quick, why, if I have x squared minus 16, why could it definitely not be this? Doesn't negative 8 times 2 make negative 16? Why is it not this?
Because of the sign in the middle.
What would you get in the middle? Minus 8 plus 2. I get a minus 6x in the middle, right? And what am I supposed to have in the middle? Nothing. So some of you guys realize what I'm doing. I'm really trying to emphasize this point. Why does this work the way it does? The only way 2 things can cancel each other out is if they're the same number, different signs. So what's it got to be then? 4, yeah. X to make x squared. 4 makes 16. Negative, positive, or the other way around, I don't care. As long as they're different signs. So it's not really new. It's just saying what 2 numbers multiply by this and add to be 0. For 2 terms, the middle term's missing. That's one possibility.
So if you were to check it, you would just do the FOIL?
Oh yeah. And you've seen, if you think back to the foiling section, they gave you a couple like this where the middle term cancels.
Okay.
So here's your x squared. Here's 4x minus 4x minus 16. So the middle terms do cancel. So you can check that kind of problem pretty quickly.
Well, can't you just look at it and see that it's 2x's and then negative 4 times 4?
That's my point. So I'm trying to get away now from looking at it as a 0 in the middle and it's a 3-term problem. It's actually now let's make a pattern for a 2-term problem. What do? One of each of these, one of each of these. When I break it in half multiplication-wise, right? 16 is 4 times 4. X squared is x times x. One of each, different signs. So let's try another one. Y squared is y times y. 49 is 7 times 7.
Positive 7, negative 7.
Yeah? So I put one y there, one y there, 1 7 there, 1 7 there. Plus minus.
That is a think up.
That is a think of problem. All right. All right. I'm starting to get people, some people like, no, it ain't. Thank God problems are what he left blank. No. What about this here? Okay, just up the ante a little bit. I don't care if I put more stuff in there. Same idea. You break everything in half. So it's part of this. If I would have put an 80 there, you couldn't have done anything. It's got to be something that can be broken in half multiplicatively, not 40 and 40. It's got to be like 9 and 9. So A4 would be what and what?
A2.
You got to love it, right? 2 and 2 to make 4. Minus plus. 9, 9. MM. Do you see that? Up here, do you see how the 9s and the M's are together? So they better still be together in your answer. I start to see the 9 kind of like floating over here. How the hell can it do that? It's got to stay where it is. Yeah.
Would you ever see it if it was just an M by itself?
If you just saw an M, can you cut it in half?
No. No.
Well, I got to be careful. I don't want to get too weird. You could actually force the issue. We're going to stick with it has to come out to be whole exponents. So it can't do half of a letter.
Good.
In real life, you actually could if you want to be crazy. But we're going to stick with just full variables and real squares for numbers. Right? Let's take the next step up here. How about,
Sounds good.
stay with me now.
Are they always going to be minus?
Oh, good point. We'll talk about it in a second. Well, let me say it right now. What's the only way two things can cancel when you add them together?
They're opposite signs?
If they're opposite signs, they're always going to multiply be
And then,
negative.
okay.
So what can you never do with the sum? If I put a plus there, it's prime. Unless there's a GCF that'll come out, a sum of squares cannot work. Let me say this again. The main reason that a difference of squares works is because I have to have different signs to make the middle term cancel. Therefore, I have to have a minus for my product, for my multiplication. So if somebody put a plus there, screw them. Actually makes the problem easy. You just say prime. Don't do any work. I cannot factor a sum of squares. Cannot factor a sum of squares. So let's focus on this one, then I'll give you an example over there. So what's the first step on this guy? How do I know I can do it, by the way? How many terms are there?
2.
2. And can everything be cut in half?
Yes.
Yes. 25 is 5 and 5. 16? 4 and 4. A6? A3, A3. So if I saw an A7 there, unless there was another A so I could take a GCF out, I can't do squares to it, can I? Because I can't cut that in half. and still have a whole number up there, right? So now, I think some of you guys are starting to realize why this is a thank God problem. So if you see two terms and everything can be cut in half, you say, thank God. Cut everything in half, minus plus. Or plus minus, if you like that better. So what's 16? 4 and 4, A6? A3, A3. So that takes care of my 16, A6 there, right? Plus minus, I love it. 5 and 5. Y and M. There you go. You can always check yourself too. What's up?
No.
I
got it.
Sweet. So let difference of squares be that easy. Do you see how I've gotten us to a point where I got all kinds of shit going on? And it really isn't that difficult? So, but what if this is in the middle of all different types of factoring problems? That's where people make mistakes. Because you don't just take a second and say, oh, there's two terms, it can only be this kind of thing. Attack it that way. People start to do 16 times 25, all this weird shit, right? I just am like, damn. So let's talk about the squares here, the sum of squares. So if you thought the answer was this, and you can see why somebody might think it's this, why are they wrong? Because the middle term doesn't cancel. You get plus 2x, you get plus 4x. Is there a plus 4x there? So that obviously can't be right. And then they go, well, maybe it's this here. And then you say, it's the same damn problem, dude. Minus 2x. That's why a minus sign is actually what allows this thing to work. The minute I put a plus sign there, it's not going to work. It can't possibly have things cancel.
So what's that called?
That's a sum of squares, and you would actually call this prime. So it's a sum of squares. Cannot factor. Now you know I've got to follow that up with a counterexample here. Is that a sum of squares?
No.
Try it again. Can everything in there be broken in half?
Yeah.
Isn't 4 2 and 2?
Yes.
Y and Y, 4 and 4. So I can't factor it like a squares. But what can I do that I always try no matter what? GCF. So that's the one thing I want to be careful about. You can't factor it based on the squares piece, but you can always try GCF. GCF is always like, I might work. So what comes out here? 4. So you're left with a true sum of squares that you can't go any further, right? So you stop right there. Okay. How are we doing so far? All right? Yeah.
So this segment, 4y squared minus 16. So I start with GCI or I start with
Either way, I would highly recommend you start with GCF. And let me show you why. What could come out of both of these?
4.
4. And then what could you do with this?
Yeah, 1 minus.
Isn't that y and y? 2 and 2. So you could put a y and a y, a 2 and a 2, and then plus or minus. Plus and minus. If I don't take the 4 out first, can't I still do it? 4 is 2 and 2. Y squared, y and y. Plus minus. Each of these, though, are they done?
No.
Each of them has a what?
2 you can do.
Yeah, I can take a 2 out of here and a 2 out of there. So 2 times 2, you still end up at the same place. It's just that it looks a little freakier that way. So that's why I highly suggest that you do GCF. Always try that first. Get that out of the way.
That might sound silly, but that's not 2 times 2. Or wait, I mean 2, that's the same thing, isn't it? Yeah, okay.
Yep. Cool.
Never mind.
Okay. All right, guys. You want to take a break?
Do I have to come back?
This is college. You don't even have to be here, really. But I appreciate that you are. But if you want to, come back, please do, a little after 4:30, let's say, almost 4:35.
Do you have any quizzes, Joe?
What's up?
Any paperwork to do?
Oh, yeah. There you go.
Oh, yeah.
Thanks.
Do I have another grade sheet, or this the last grade sheet that you need?
I think that last one was I didn't give out any more than that.
Okay.
Yeah.
Alright.
No. I keep forgetting it's not really part of what I normally do, so I always forget to ask if you need to. Here. And Dave. Oh, yeah. Oh. It's not too late. It's late, so you won't maybe get as many as you would have, but you can still do it, yeah. Guess it shouldn't be.